A box contains 3 white balls and 4 black balls. So 3 white and 4 black. A ball in part A here, a ball is drawn at random from the box and not replaced. That's an important word there. Then a second ball is drawn at random from the box. Draw a tree diagram for this experiment and find the probability of the event that the 2 balls are the same color. Okay, so they're showing us 4 possible tree diagrams, and we have to decide which one of those is correct. So let's think about what happens. The box has 3 white and 4 black balls. 3 white and 4 black balls. So the first draw, this branching here, and this branching here, and this branching here, and this branching here, they're all showing the first draw out of the box. We got to decide which one is correct. So, which one of those is actually correct? Well, there's a 3/7 chance you're going to get white because there's 3 white and 4 black. So when you first draw out of the box, 3 out of 7 are white, 4 out of 7 are black. 3 out of 7 white, 4 out of 7 black, 3 out of 7 white, 4 out of 7 black, 3 out of 7 white, 4 out of 7 black. Those are all correct. They all have that right. But what's going to happen on the second draw? That's where things really get interesting. On the second draw, let's say you go this way. Let's just follow the branching in part A and see if part A is right. What if you get a white marble? So can you picture the box? So we have, let me draw a box. We have a box. It's got 3 whites and 4 black marbles in the box. What if we go this way? So whenever you do a tree, you're assuming that happened when you take a branch in a tree. So let's suppose you got the white marble. So what if you got the white marble out? Then you're going to take out a white marble from the box. What's going to be left in the box at that moment? 6 marbles, right? It's not replaced. You don't put back the marble. You take out the white marble. It's gone. So now there's only 6 marbles left, not 7. That's wrong. There's only 6 marbles left. And what's the chance the second one? So this is the first draw, the second draw. First draw, second draw. First draw is either white or black. Second draw is either white or black. First draw is white or black. The second draw is the second branching. So what's the chance that the second marble is going to be white? Well, 2 out of 6. 2 out of 6, which reduces to be 1/3. It should be 1/3 on that branch. That's what D has. See how D has the 1/3? Chance of blue is going to be, black is going to be 4 out of 6, which reduces to be 2/3. See, this was 2 out of 6, which reduces to be 1/3. Because if you got a white out the first time and took out that white, then there would be 2 out of 6 whites left to get white the second time, which is 1/3, which is what they have. There'd be 4 out of 6 black. Out of the 6 marbles left, 4 of them are black. That's a 2/3 chance of getting black the second time. And then, what if, let's go down here now, what if you got black out the first time? So you have your box, you've got, well, here I better not put it right there where I'm trying to work. You have your box, I'll do it over here, and you have, what was it originally, 3 whites and 4 blacks. Now what if on the first draw, so we already did the first draw white, we took care of that. Now first draw black, that means you took out one of the black marbles in the first draw. So what's left for the second draw? 3 white, 3 black, so it's half white, half black. D has everything right. Half white, half black for the second draw. So now, what's the probability of the event that the 2 balls are the same color? So to figure that out, we need to come over here. We now know this table is correct. So we've got to draw the ends of each of these branches. So this is white, white. This is white, black, which means you got white out the first time, then black. This is black the first time, then white the second time. This is black the first time, then black the second time. What are the probabilities of these various things? You just multiply 3/7 times 1/3. Oops. Let's try that. 3/7 times 1/3, cross cancel, 1/7. That's the probability of getting white then white. What's your chance of getting white then black? Well, it's 3/7 times 2/3. 3's cross cancel. 2/7 chance of getting white then black. What's the chance of getting black then white? 4/7 times 1/2. And 2 goes into 4 2 times. 2/7. Last one, what's the chance of getting black then black? 4/7 times 1/2. Again, 2 goes into 4 2 times. 2/7 is the chance of black then black. So there's 4 different things that can happen, right? We're drawing one marble out the first time, not putting it back, not replacing it, and then drawing a second marble out. We could get white and white. Chance of that is 1/7. White and then black, the chance of that is 2/7. Notice we multiply. This whole section, section 9.2, is multi-stage experiments, meaning we're going to do one thing and then another. So we're drawing out one marble and then a second marble. So whenever you do 2 things in a row or 3 or 4 things, you multiply those probabilities. See how I'm multiplying each of these probabilities? Chance of getting black and then white, we multiplied and we got 2/7. Black and then black, we multiplied and we got 2/7. So what's their question? Did you get 2 balls of the same color? Well, there's 2 ways to do that. You could get white and white. That'd be 2 balls of the same color. Or you could get black and black. So you could get white and white or black and black. Those are going to be added because it's or, it's not and, right? You can get white and white, that's 1/7, or you can get black and black, that's 2/7. Add those up. 3/7 is the probability that you're going to get 2 balls of the same color. So that's a tricky question. Let's go down to part B now. Part B, going to change things up a little bit down here. It says, suppose that the ball is drawn at random from the box, its color is recorded, and then that ball is put back. Ah, do you see that difference? Put back. Look back up here at part A. Not replaced. We did not put it back in part A. We took the first ball out and did not put it back in part A. But in part B, we are putting the ball back in the box. Let's go on. Then a second ball is drawn at random from the box. Draw a tree diagram showing the probabilities. Okay, so now it's going to be a little different story. So what do we have in the box again? We have, I forgot already, 3 white, 4 black. Okay. So 3 white, 4 black. So what's the probability of white? 3/7, black is 4/7. All of the branches start that way. That's your first pick. So suppose you pull out a black the first time, but then you're going to put it back. So when you come to your second draw, it's going to be exactly the same as the first draw. It's going to be 3/7, 4/7, 3/7, 4/7. D has got it. You see, the second draw is the same as the first because you put back the marble you got the first time. So there's nothing different. The second time you reach in the box, it's the same group of marbles as the first time. Whereas back here on part A, remember, we did not replace the marble. So when we took out the white on the first draw, that changed the ratio of black and white for the second draw. Or when we took out black on the first draw. That changed the ratio, changed these fractions in the second draw. That's harder when you don't put it back. All right, so then final question, they want us to find the probability that two balls of the same color. So remember how we do that? We got to go, okay, white and white, white and black, black and white, black and black. And we just follow the branches. 3/7 times 3/7. Multiply those together, 9/49. Then 3/7 times 4/7. Nothing can cross cancel here, right? 3 doesn't go into 7, 4 doesn't go into 7. So 12/49 is the chance of white then black. 9/49 is the chance of white then white. Let's keep going. 4/7 times 3/7. 12/49 is the chance of black then white, and 4/7 times 4/7, 16/49 is the chance of black then black. Now what did they want? Two balls of the same color. Two of the same color. Well, that's black and black or white and white. So black and black is 16/49 plus white and white, that's 9/49. So we add those up and we get 25/49. And that's our answer. We can't reduce that fraction.